Okay, trig and pre-calc. We're talking about 8.5, Kramer's rule. In this section, we are learning how to use the determinants in different ways. So the three paragraphs that explain Kramer's rule at the top of your 8.5 notes in the back page there kind of explain what Kramer's rule is, but I think that specifically the third paragraph is kind of wordy and hard to understand. So I'm going to go over what that says real quick. So it reads, the solution to the system uses determinants to write the solutions to a system as fractions with numerators and denominators that are determined by various determinants within a matrix. No commas, no punctuation other than a period at the end, lots of big words. So I don't blame you if this doesn't make sense to you. But what this is saying is that the solution we find when we use Kramer's rule, it ends up as a fraction, and in the numerator of that fraction is a determinant, and the denominator of that fraction is another determinant. And those determinants are found within the matrix, the original matrix. So that's what we'll be doing with Kramer's rule. And let's remember with matrices that matrices represent systems of equations. So up here, forgive me for the light ending right here, but this is a1x plus b1y equals c1, and a2x plus b2y equals c2. And this is the normal form for any 2 by 3 per se system of equations, and this is how that would look as an augmented 2 by 3 matrix. And so this is what we'll be using as the generic form to fill in for these letters. Like this is where we get these letters from. A1 represents the A1 position, B1 represents the B1 position, so on. So it'd be nice maybe to have this written out somewhere so that you know that if this is a matrix full of numbers, you know where, or you know which numbers to choose for what. So let's get into it. When we use Kramer's rule, we'll take, or to find x, we'll see that the numerator is c1 times b2 minus c2 times b1, and the denominator is a1 times b2 minus a2 times b1. And let's notice that these numbers are alternating, right? So that changes the number, the row number, because we have row 1 and row 2, and then we have column A, B, C. So this one we have alternating rows and alternating columns, and same with this one. And that pattern we've already seen before with determinants. So if we take this matrix, which we got from our original, and since we're finding the x value, we're going to replace, in the numerator, we're going to replace the x values with the solutions. So see how we have the solutions? We have column C here, and we have column C here, and then we have column B. Similarly, when we find the y values, we take the C column and we replace it with the B column because those are the y coefficients. So notice how when we're looking for x, we replace the A column with the answers. Then when we're finding the y, we replace the B column with the answers, with the solutions. And in the denominator of both is the coefficient matrix. And we will establish exactly what that is down here, but I believe we've talked about it already. So that's just going to be A1, B1, A2, B2. And that will be the denominator in both of our solutions. So let's go through and we'll go and give the coefficient matrix, the denominator, dx, which represents this matrix, and then dy is this matrix. So dx, I'll write that right here, equals dx, and this equals dy. So the numerators of those fractions there are going to be dx and dy, respective to whichever variable you're trying to find. So with this one, our matrix is going to be 2, -5, 3, and then -4, 3, 8. And we'll augment that as well. So let's look at what pieces we have to put together. Let's do the coefficient matrix first because that's pretty easy. We'll just look at the coefficients. So we'll cover up the solutions and we'll see the coefficients connected to the variables. We've got 2, -5, -4, and 3. So 2, -5, -4, and 3. Sorry, that kind of looked like a 2 minus 5. So we've got 2, -5, -4, and 3 as our coefficient matrix. And so the thing that will go in the denominator when we find the solution is going to be the same thing. It's just going to be A1, B1, A2, B2. So let's take A1, B1, A2, B2, and put it in the denominator matrix. So we've got 2, -5, -4, and 3 again. And so remember, dx is going to be this matrix. So dx is the matrix that's in the numerator when we're finding the x variable using Cramer's rule. And it's going to consist of the matrix that replaces the A column with the solution column, the C column. So let's replace this column with the solution column. So we'll move that over here temporarily. And so our dx matrix is going to end up being 3, right? Because that moved over. -5. 8, because that moved over. And 3. And so this is what would go in the numerator over this when we were trying to find the solution to x. Yeah. And remember, we would find the determinant of these and then put them in the numerator because this is determinant notation here. These aren't just matrices divided by matrices. These are determinants divided by determinants. So it ends up just being a normal fraction. Should have explained that in the beginning. I'm sorry if that was confusing. But so these are the determinants. This is just how that's represented. And so we're finding the matrices down here, which we can then use to find the determinants if we were to continue on with this example. But anyway, we'll move on to dy. So similarly, we'll replace the B column with the C column so that it's just the A's and the C's like we have over here. So A, we have 2. A1 is 2. C1 is 3. A2 is -4, and C2 is 8. And so with the dy matrix, what we did was replace this column with that column and rewrote the matrix. And so like I said, if we were to continue on with this example and solve for x and y, we would put this, we would put dx over d and find the determinant of both of those, and then we would put dy over d and find the determinant of both of those. And those would give us the solutions in fraction form of x and y. And so I will have one more video going over a full example, and then I want you all to try the other one on your own.